Good afternoon. My presentation is in English, and I was asked to speak in English. I think I am going to do it this way for the benefit of all of those people whose first language is English and not Spanish. But I'm sure that, well, if I'm not sure about the words, I am going to say some things in Spanish. Right now, I want to break what we have been presenting. For some days, I have been presenting what the Sub-Ministry of Communications is going to do. It is going to be transformed into a text company.
My presentation, when I saw the name of the panel, I thought data in the economy, in the digital economy. And I said, well, let's think about data as an isolated thing, and then let's construct something around data and what we are looking right now, that it's the fourth industrial revolution. And the next one, please. We believe that data, and we have heard in all our influential markets in the telecommunications sector, that data is the core element of the new telecommunications and ICT networks. And then I extracted from the internet some ideas of what does data really means isolated. And data by itself is not really doesn't mean anything if we don't associate data with other things. And then I scratch a little bit into the different sources of information, and I found something that said, part of the fourth industrial revolution is the manner in which all types of machines and devices interact, communicate, and learn from each other. And what does data mean in this respect? It means that we are aggregating information, we're aggregating data, and we're putting it together in certain element devices that are collecting this information and put it in a database and then providing more information for us. But does this make sense to us as an isolated item, the Internet of Things? No, I think it doesn't make sense. But if we connect all this isolated information and put it together and then build another database or exchange data from one side to the other, then we can build something that might be interesting for us. Then I learned from another source of information that in manufacturing, for example, improvements and efficiencies in the analysis of big data, that means a lot of data, are expected to bring $1 billion to the industry over the next 5 years. So then I started thinking, oh, maybe putting together all this data and doing something with it in different sectors might help me understand how I can improve efficiencies, how can I be more productive, and then bring a different business model to the activity I'm doing. And this is the case of the manufacturing. But then I went to other sources to see if the financial services were doing the same thing. And in the financial sector, some have concluded that big data is the new electricity and the power source driving change on the way that steam did in the first revolution, electricity in the second revolution, and the digital technology in the third revolution. So then I understood why data is the core business of the industrial revolution. And then I said, well, but we started with the connectivity and the gathering of data through IoT, and putting all these databases together. But we need to have something else. And then I realized that there was another topic in the market that is continuously bringing our attention in the telecom and ICT sectors, that is artificial intelligence. I studied 40 years ago computer science, and one of my courses was on artificial intelligence. But the difference from then to now is that the algorithms and the way we analyzed in artificial intelligence was practically incipient. Nowadays, we know that the algorithms are becoming more complex, that the networks are becoming more complex, and that they interact humans with humans and devices and other elements connected to the network with each other. And in this case, artificial intelligence sums to the equation of Internet of Things, of big data, and bring us new ideas for the digital economy. The next one, please. Next one, please. So I'm thinking, as a new part of the government, what should we do in the present to build a future that would be beneficial for the users and that bring us a good sense of life for our communities where we live, for our work, and for our society as a whole. So I think, in the end, that we need to build upon these new ideas that are being evolving, that have been evolving, and we need to put them together, the artificial intelligence, the Internet of Things, and big data. And then, if we put them together and build good policy initiatives, then we could become leaders of this new fourth industrial revolution. But then I was thinking, well, these three aspects are threatening the jobs that we know today. And I asked myself, what about jobs? What is going to happen with the new jobs? The new jobs definitely are going to be centered in these areas of expertise, and we will need to be building capacity, and we will need to train and give all the tools and abilities to our students to become experts in these areas. But then I said, well, what's going to happen if some of the news say that in the year of 2055, half of the jobs will be automatized? So what's going to happen with the rest of the people? I am not really concerned about this, because then this fourth revolution is going to change the way we live today. And perhaps it's going to change in a very good way. I think that the change of paradigms is going to be that we're going to be focusing more on exclusively human activities, not activities done by robots. That means invention, that means art, that means science, and that means exploration. So I think that it is not really bad that we're getting into this fourth revolution. And please, the next one. Let me show you why. Next, I'm going to show you something that happened in the 16th century. I don't know how familiar are you with kirigami art. This art is the art to cut paper. And these papers are cut in different sizes and algorithms to show how flexible the production of these papers, how flexible they could be, or how strong they could be that they don't break. And they eventually give us shapes that are really nice to look at. Well, these past challenges that they had in the 16th century are coming into the new century for people that were looking at new ideas to use electronics. And they are using it, cutting nanomaterials and polymers in order to build more flexible devices that you could use in the future, supporting large amounts of data that you could have. Either you could wear them or you can use it in many places. And please go to the next one. And this is getting information from the past to use it for the future. Next slide, please. Now, let me tell you a challenge of the present to serve of the future. And this has to do also with the telecommunications sector. Yesterday, there was a presentation by one of the research centers of Canada saying how they can build a connection between data, starting from data, a connection through 3 elements, which is the first one, getting the spectrum environment awareness, survey all the resources through analytics, data aggregation, and intelligent, an intelligent cache tracking, and as also including another step of increase the supply by breaking the frequency barrier of beating the spectrum, and also optimizing the resources, making better use of the spectrum. And with data, you see that data is really relevant. Data science, for example, for scientists to allow for new products, new services, could bring, in this case, automated assignment, dynamic rules for the use of spectrum, and also automated compliance when reviewing that all the spectrum is correctly used. I want to stop here because I think I wanted to open the discussion of the future of the digital economy by showing you that analyzing data as a single element and then interacting with different elements that we will be seeing right now and in the future that show us that we can do very interesting things for the future, and then we can live a good life by using our humanity in a good way. Thank you very much.